Lesson 4 of the hardware topic is all about the CPU. First, a quick starter. Can you define these things? The CPU, the primary storage, and the secondary storage. Well, let's have a look. We should have said that a CPU is a central processing unit and that it fetches and executes instructions from memory. Fetch and execute instructions from memory, main thing you need to remember about the CPU. Primary storage is temporary storage for data and programs that are currently in use. It's fast, but it's small and it's volatile, which means it loses its information if the power is disconnected. And secondary storage is permanent, it's for files and programs, but it's slow, although very big, and it's non-volatile, so it can keep data even when the power's gone. Last lesson, we looked at how adding more RAM to a computer can speed it up. It means there's less access to secondary storage, which is the slowest thing a computer does. But even with plenty of primary storage, a PC is still limited by the speed of its CPU. There are several factors that affect the speed of the CPU. In this lesson, we're going to learn the 3 main factors that affect the speed and why those 3 factors make a difference. Adding more RAM and choosing suitable secondary storage can make a big difference to the speed of a computer, but ultimately the CPU is a major limiting factor. Different CPUs run at different speeds, and these speeds are controlled by 3 factors: the clock speed, the number of cores, and the cache size. Well, first let's look at the clock speed. The job of the CPU is to fetch and execute instructions, we know that. It does this many times per second, billions of times per second in modern CPUs. But how many times per second is dictated by a component on the CPU called a clock. A clock is a very simple component. All it does is send a regular pulse to the CPU, telling it to fetch and execute another instruction. Every time the CPU receives this pulse, it fetches the next instruction. So if we use slow pulses, it fetches and executes at the same speed as the clock. If we speed that up, it fetches and executes quicker. More instructions are fetched and executed in the same amount of time, therefore the computer is faster. In the early days of computing, the clock speed was the speed of the computer. If your computer had twice the clock speed of your neighbour's, then your computer was twice as fast as your neighbour's. For about a decade, the clock speed of a new processor would be double that of the old one, and computers got exponentially faster. PCs in the mid-1990s ran at 133 megahertz, that's million cycles per second. By 2005, 15 years later, the first CPU to run at 3 gigahertz, 3 billion cycles per second, was released. But if you look online now for processors, you'll find that most top-end CPUs still run between 3 and 4 gigahertz. So why haven't clock speeds increased for 15 years? Well, fast clock speeds means more electricity is needed. More electricity means more heat, and any faster than 4 gigahertz needs industrial cooling to avoid melting the processor. Prior to 2005, processors were made more efficient each couple of years by using smaller transistors, which required less power. So then clock speeds could be boosted to get the power back to where it was. We're now as small as silicon components can go, so clock speed has reached its limit. Here's some notes I'd like you to make on clock speed. Clock speed is the number of clock cycles per second measured in hertz or kilohertz or megahertz or gigahertz that a CPU receives. Each clock cycle is a signal to fetch the next instruction. However, some instructions take multiple clock cycles to execute, so a 4 gigahertz processor doesn't necessarily fetch and execute 4 billion instructions every second. The faster the clock speed, however, the faster the computer. With the limits of clock speed reached, we need to find new ways to improve processing speed. One way to do this is to increase the number of cores. Each core is an independent processor on board the CPU. A quad-core processor, for example, has 4 cores, so theoretically can do 4 operations every clock cycle, 1 on each core. So does this mean that a quad-core CPU is 4 times as fast as a single-core CPU? Well, sadly not. Think of it this way. If a CPU wanted to calculate 4 times 3 plus 6, 2 operations need to take place. First, add 3 and 6, and then multiply the result by 4. This can't be divided between the 2 cores, as the second operation requires the result of the first. So even if a second core took that second operation, it would have to wait for the result from the first core. Multi-core CPUs don't speed up linear operations like this, and a lot of what a computer does is linear operations. Multi-core CPUs only speed up operations that can be split between the cores, like video decoding or multitasking or games. Notes on multiple cores. A core is an independent processor. More cores on a CPU mean more operations can happen at the same time. But this only affects operations where the tasks can be split between cores. The third and final way to increase the processing speed that we're going to look at today is to make use of cache memory. Cache memory is a small area of extremely fast storage on board the CPU. This is built into the CPU. It's not something you can upgrade or add to your computer. If the CPU detects that it's fetching and executing the same data from RAM repeatedly, then that data is copied to cache memory. Next time the CPU needs to fetch that exact instruction, it's already in cache memory, so it can execute right away, skipping the fetch step. Notes on cache memory. Cache memory is fast storage on board the CPU. It's used to store frequently used instructions and data. Having data in cache means the fetch step can be skipped, speeding up execution. More cache means more fetch steps can be skipped, improving the speed of the computer. Your assessed task for this lesson is to go onto Amazon or any other online retailer and search for a CPU. Choose 3 CPUs, a high-end one, a mid-range one, and a budget one. Use the price as a guide. Paste screenshots of the specs for each one into Word and compare the 3 of them in terms of clock speed, number of cores, and cache size. You must explain what these things mean and what benefit it would provide. Here's an example, highlighting that it's got quad core and then explaining what that means, highlighting that its clock speed is 2.4 gigahertz and explaining what that means.